Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to factor polynomials. Our focus in this presentation will be on binomials. This standard is covered in Algebra 1, Algebra 2, and Pre-Calculus courses. Don't forget there are 12 practice problems at the end of this presentation that we'd like you to do to demonstrate that you've mastered the content that's covered in this video. To gain access to the entire course list and other valuable resources, just take a look at the link in the description below, or you can just visit our website at mathgotserved.com. Alright, so the instructions for the problems that we're going to be working on are as follows. We have to factor the following completely. Alright, so let's go over the plan that we're going to be employing to carry out the factorization process. So our plan of attack is as follows. What we're going to do first is we're going to decompose each term. Okay, so we're going to decompose each term. Now, why is it that we're decomposing each term? Well, the reason why we're decomposing each term is because it makes it easy for us to identify the factors that they have in common. Okay, and then after decomposing each term, we're going to factor out common factors. All right, so that's the plan of attack. Let's take a look at question number 1. Let's say we have 7x plus 14. How do we factor this? If we have 7x plus 14, first things first, we're going to decompose both terms, okay? So 7 is prime, so that's 7 times x plus, and then if you want to, let's break down 14, okay? When I'm talking about decomposition, I'm talking about prime factor decomposition. You break it down into its prime factors. So if you break down 14, using factor tree is going to be 7 times 2. All right, so now that we've factored both terms completely, we can look to both sides of the sign and ask ourselves which term is common. And here we can clearly see that 7 and 7 are common on both sides, so that's our GCF right there. So we're going to factor it out. Okay, when we factor out 7, it is as though we're dividing by 7, so they're gone, and we'll be left with x plus 2. All right, so this is the factored state of question number 1. All righty, let's take a look at question number 2. So for question 2, let's say we are to factor 4c minus 8. Okay, now to do this, we're going to employ the plan that we outlined earlier, which is to first of all decompose each term and then we factor. Okay, so 4, if you use your factor tree, you can break down 4 into 2 times 2. So we have 2 times 2 times c. And then 8 is a little bit bigger, so let's put 8 to the side. So to decompose 8, we take out 2. 2 goes in 8 4 times. 2 goes into 4 2 times. So 8 is 2 times 2 times 2. Alrighty, so we're looking for the greatest common factor to the left and right of this operation, this subtraction operation here. So we have 2 and 2, and then we have another 2 and then another 2. Okay, so what we're going to do is we're going to factor them out. 2 times 2, so factor out 2 times 2. When we factor out 2 times 2, it's as though we divided both sides by 2 times 2. So those are gone, and then you're going to be left with what? Let me show you what's going to happen. So these two 2's are gone, these two 2's are gone, so you're left with c minus 2. Okay, so we'll bring that down. C minus 2 is what is left. And then we can simplify further. 2 times 2 is 4. Now this 4 that we factored out is known as the GCF. Okay, 4 times the quantity c minus 2 is the answer to question number 2. All right, let's move on to number 3. For question 3, let's say we were to factor 2x plus 10y. All right, we're going to follow the same procedure. that we use for 1 and 2. So let's rewrite the problem. 2x plus 10y. We're going to go ahead and decompose 2 times x plus, if you break down 10, it's 2 times 5 times y. All right, so look to the left and right of the minus sign. What do we have that's common? 2 and 2 are common to both sides. So what we're going to do is we're going to factor it out, okay? So we factor out the 2 and the 2, we're going to be left with x plus 5y. All right, so bring that down, x plus 5y. And that's the answer to question number 3. All right, let's take a look at question 4. So for question 4, let's say we are to factor 12m minus 30n. We're going to follow the same procedure, okay? So the solution is as follows. We have 12m minus 30n. What we're going to do is we're going to decompose both of them. Let's start with 12. So let's break down 12 into prime factors. 12 is even, so 2 goes into it. 2 goes into 12, 6. 2 goes into 6 3 times. So we have 2 times 2 times 3 times m as a decomposition of 12m. And then let's move on to 30. Let's break down 30. So to break down 30, 2 goes into 30 15 times. And then 3 goes into 15 5 times. So the decomposition of 30 is 2 times 3 times 5. Oh, and then we have the n times n. All right, so what's common to both terms? To the left and right of the negative sign, we have 2 and a 2 are common. We have 2 and a 2, and then a 3, and then a 3. Those are common, okay? So those will get factored out. So we have 2 times 3 on the outside, and then we're going to be left with 2m minus 5n. Okay, and then to simplify further, 2 times 3 is 6. 6 times 2m minus 5n is the factored state here, and the GCF is 6. That's the greatest common factor that we could extract. All right, moving along, let's take a look at question 5. Let's say we were to factor 20a squared plus 28. All right, so solution is as follows. Let's write the problem. We have 20a squared plus 28. We're going to decompose both terms, all right? Let's start with 20. How do we break 20 down? We have 20. It's even, so 2 goes in it. 2 goes into 20 10 times. 2 goes into 10 5 times. So 20a squared is going to be 2 times 2 times 5. A squared is a times a, okay? Plus, let's break down 28. 2 goes into 28 14 times. 2 goes into 14 7 times. So 28 is going to be 2 times 2 times 7. All right, so what's common that we can extract? What is the greatest common factor? To the left and the right of the plus, we have a 2 and then a 2. And we have another 2 and another 2, and nothing else is common. So those common factors, we're going to factor them out. 2 times 2, and then we're going to be left with 5 times a plus 7. Alrighty, now let's multiply them back together. 2 times 2 is 4, and then times 5 times a is 5a squared plus 7. Alrighty, so there goes the answer to question number 5. All right, moving along, question 6. So for question 6, let's say we are to factor 5y squared minus 35y. Alrighty, the solution is as follows. So rewrite the problem, 5y squared minus 35y. So if we break down 5y squared, that is 5 times y times y. If you break down 35, it's 5 times 7, and then times the y. Now to the left and right side of the net minus, what can we factor out? That's common. 5 and 5 are common. And then y and y are common, so we factor those out. So we have on the outside the GCF, which is 5y. And then y minus 7 stays behind, and that's the factored state of question number 6. All right, moving along, question 7. Let's say we're to factor 32CD minus 8D. Okay, so the solution is as follows. Let's write the problem. 32CD minus 8D. We're going to go ahead and break down 32 and 8, okay? If you break down 32 using a factor tree, you're going to have 5 2s. So 2 times 2 times 2 times 2 times 2 times C times D. And then if you break down 8 using a factor tree, you have 2 times 2, which is 4 times 2, which is 8, times D. Alrighty, so what are the common factors? We have 1, 2, 1, 2, we have another 2, and another 2, we have another 2. So we have 3 2s. Is that it? How about the D? We have a D here and a D there. Alrighty, so let's go ahead and factor that out. We'll factor it out. We have 2 times 2 times 2. And then on the left side, we have 2 times 2 times C. And then here, if we factor everything out, you're going to be left with 1. All right, because it's as though you're dividing by the number that you factored out, okay? All right, now let's multiply everything back together. We're going to have 2 times 2 times 2, that's 8. Oh, I forgot the D. There's a D there, so let's add that. So we have 2 times 2 times 2 times D. All right, so multiply all that together. 2 times 2 times 2 times D is 8D. 8D times 4C minus 1. That's the answer to question number 7. All right, let's take a look at question 8. So question 8, what if we were to factor 15GH minus 24H? We're going to be following the same procedure that we used in the previous problems. All right, so let's rewrite the problem. 15GH minus 24H, we're going to decompose, okay? If you break down 15, that's 3 times 5 times G times H. And then if you break down 24 using a factor tree, you take out 2, you're left with 12. Take out another 2, you're left with 6. Take out 2, you're left with 3. 2 times 3 times H. Okay. All right, now what's common that we can factor out? We have a 3 and a 3 that are common. Okay, so when you factor that out, oh wait, what else? We also have an H, right? So we have an H and then an H that we can factor out. So when we factor them out, we have 3 times H. Okay, so when those ones are divided out, it's like we divide them by 3, those are just going to be ones, right? And then we're going to be left with 5G minus 2 times 2 times 2. All right, these 2's here and the 5G. And then to simplify, we're going to have 3H times 5G minus 8. And that, ladies and gentlemen, is the factored state for question number 8. All right, so for question 9, let's say we have 11a squared b minus 33ab. So the goal is to factor that completely. So let's rewrite the problem. 11a squared b minus 33ab. So we're going to decompose this completely. 11 is prime, so we just have 11 times a times b. And then 33 is 3 times 11 times A times B. All right, so let's look for common factors that we can extract here. We have an 11 and an 11. And then we have an A and an A. And then we have a B and a B. All right, so those will get factored out. 11 times A times B will get factored out, and we're left with A minus 3. Okay, so let's simplify it. 11 times A times B is just 11AB times A minus 3. And that's the answer to question number 9. All right, moving along, let's take a look at question 10. So for question 10, what if we were to factor 36bc squared plus 45bc? Alrighty, let's do it. So we have 36bc squared plus 45bc. We're going to start by breaking them down, decomposing each term. If we decompose 39, we will have, using our factor tree, 3 times 3 times 2 times 2 times b times c. Okay, and then for 45, it's going to be 3 times 3 times 5 times b times c. Okay, so what are the common factors that we can extract? We have a 3 here and then a 3 here. We have another 3 here and another 3 here. And then we have a b, and then I have another b here. And then we have a c and a c. All right, so those common factors can be extracted. That's the GCF. The GCF is 3 times 3 times b times c, and we're left with 2 times 2, 2 times 2 times c. There's a c there. Let's move this to the left a little bit. All right, so we have 2 times 2 times c, the c that's left here, plus 5. Okay. All right, so let's go ahead and simplify it completely. If we do that, we have 3 times 3 is 9 times bc, so we have 9bc times 2 times 2 is 4, 4c plus 5. And there goes the answer to question number 10. All right, moving along to question 11. Let's say we were to factor the binomial 2ab minus a. All right, let's look at that. So we have 2ab minus a. So we decompose it completely. We have 2 times a times b minus a. All right, so the common factor is a and a. So as though we're dividing both sides by the common factor a and a. So pull that out, we'll factor out a. And then we're going to be left with 2b. If you take out an a from a, you'll be left with 1. All right, so there goes the answer to question number 11. A times the quantity 2b minus 1. All right, let's look at the last one. What if we have y squared plus 5xy? Let's factor that completely. So we have y squared plus 5xy. So we decompose the first term. We have y times y plus 5 times x times y. Now, what is the GCF that we can pull? What are the common factors that we can pull out here? We can pull out a y and a y. That's common. So we have y times the quantity y plus 5x. And that, ladies and gentlemen, is the answer to question number 12. Alrighty, ladies and gentlemen, how well did you master the contents of the presentation we just covered? In order to demonstrate mastery, we have 12 practice problems that we told you we're going to show you at the end of the presentation. So what we'd like you to do at this time is go ahead and pause this video, and we'd like you to factor out these 12 problems, okay? When you're done factoring them, reinitiate the playback, and you will see what the answers to these problems are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. The answers to the practice problems are as follows. For number 1 is 5 times the quantity x plus 3. For number 2 is 10 times the quantity y minus 1. For number 3 is 7 times the quantity x plus 3y. For number 4, it's 8 times the quantity 2m minus 5n. For number 5, the answer is 3 times the quantity 3a squared plus 7. For number 6, the factored form is 2y times the quantity 4y minus 15. For number 7, the answer is 3. For number 7, it's 4d times the quantity 3c minus 10. For number 8, it's 2h times the quantity 9g minus 10. For number 9, it's 3ab times the quantity 7a minus 9. For number 10, the factored form is 3bc times the quantity 3c plus 11. For number 11, the factored state is x times the quantity z minus 1. And then for number 12, the factored state is a times the quantity a plus 6b. Alrighty, so how well did you do with these practice problems? Let us know in the comment section below how well you did. If there are any questions that you have, or if you want any problems further clarified, just specify it in the comment section below and we'll do our best to assist you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of polynomial and the factorization process, do give us a like or thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, as indicated earlier, just put it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our page. We upload videos to our YouTube page on a regular basis, so subscribe and hit the notification button for notification of future updates. Don't forget to check out the links in the description below and also our site mathgotserved.com for tons of support resources. Thanks again for watching and have a wonderful day. Goodbye.